What is Python's diamond problem in multiple inheritance? Imagine building a family tree where two siblings share the same parent, and then a child inherits traits from both siblings. Now, picture this happening in programming with classes. That's what the diamond problem is all about. When you use multiple inheritance in Python, things can get a little tricky. It happens when a class inherits from two classes that both share a common ancestor. The shape of this inheritance looks like a diamond, which is why it's called the diamond problem. In object-oriented programming, inheritance means a class can take on properties and methods from another class. Python supports multiple inheritance, so a class can inherit from more than one parent class. For example, you might have class A at the top, then classes B and C inherit from A, and finally class D inherits from both B and C. This creates a diamond shape. Now, if class A has a method called M, and both B and C override this method with their own versions, then class D faces a question. When you call M on an object of class D, which version should it use? B's or C's? That's the core of the diamond problem. Python solves this issue using something called the method resolution order, or MRO. This is an algorithm that determines the order in which Python looks for methods in the inheritance hierarchy. When you call a method, Python follows the MRO to find the first class that has that method. So if class D inherits from B and C in that order, Python will look in B first, then C, and then up the chain. If you change the order of inheritance, the method it calls can change too. For example, if you define class D as inheriting from B and C, calling D, M, will use B's version of M. But if you define class D as inheriting from C and B, then calling D, M, will use C's version. This order is determined by the MRO, which Python calculates automatically. Understanding this is important because it helps you avoid unexpected behavior when designing classes with multiple inheritance. You can control the method calls by carefully ordering your base classes. You can also use the super function, which respects the MRO and calls the next method in line. If multiple inheritance gets too complicated, sometimes it's better to look at alternative designs like composition, where you combine classes differently. In short, the diamond problem is about ambiguity in multiple inheritance when two classes share a common ancestor and override the same method. Python's solution is the method resolution order, which makes sure the right method gets called based on the order you specify. Knowing how this works helps you write clearer, more predictable code when working with complex class hierarchies in Python.